Okay, so we're going to be webcasting the lectures from now on so that all of us are going to be having video references. And thanks to our colleague here, Abdullah Suruji, who made that possible. We're going to be reviewing today. We're going to be touching upon some fundamentals that that many of you have missed over the course of the first week of classes. We're going to be reviewing the fundamentals and then addressing a major application in finance, which is fixed income securities pricing. Okay, so let me start and what is finance? Again, what is finance? Let me go ahead and review the basics again. What is finance? This is something we covered over the first week of classes. Let's go over it again just to make sure we are going to be speaking the same language. We're kind of like talking out of the same premise. Okay, so finance is a highly structured discipline of economics. It's very structured, and what I mean by very structured is that we do have a major question in finance, okay? And what's more is that, lucky enough for us all, we also do have a major answer to that major question. Not all disciplines are that lucky to have a major answer to their major questions, okay? In finance, however, we are sort of like entertaining that kind of luxury. We do have a major answer to the major question we are about to answering throughout the discipline of finance. All right, so the big question of finance, every discipline, every scientific discipline has a major question, has a big question. Physics has a big question. Chemistry has a big question. Medicine has a big question. Finance has a big question. So having a big question is nothing unique to finance. This is how scientific disciplines function in the first place. The big question we have in finance is the question of how much. Is the question of how much. Okay, so the big question in finance is the question of how much. In precise terms, it's how much now. It's how much what? Huh? How much now. So how much, and it's a question about now. So the big question in finance is how much, and it's how much now. It's a question about now, okay? In academic terms, we say asset pricing. We say what? Huh? We say asset pricing. We say asset pricing. Or simply P0. So the big question in finance is P0, how much? P0 is how much now, okay? P0 is how much now. The big question of finance in academic language is nothing but asset pricing. All of finance is a question of asset pricing. All of finance is a question of how much now, is a question of asset pricing. You got it? There is nothing more to finance than just answering that question. You got it? The big answer to that question is very logical and very natural. Let's see how. So the big answer to that question is very logical. It's very natural. Well, if I were to ask you, like, how much would you pay for anything? How much would you pay for anything? How much would you pay for anything now? How much would you pay for this marker now? How much? How much would you pay for that nice cup of tea now? How much? This is the question I'm after here. How much would you pay for anything now? What's the natural answer to that question? Well, a natural answer to that question, exactly. A natural answer to that question is to go ahead and pay how much benefits you exactly are expecting to get out of it. Okay? It's very natural. We're not talking economics, we're not talking finance here. We're just talking about natural, simple logic. Okay? So how much you guys are going to be paying for anything? You're going to be paying the benefits you are expecting, right? And nothing more, and nothing less. And nothing more, and nothing less. So this is nice so far. So the big question is how much? The big question is how much? The big answer is expected benefits. Is what, huh? Is expected benefits. Because it's very natural to pay for something the benefits you are exactly expected to get out of it. Okay? It's very natural to pay for something the benefits you are expecting to get out of it. Okay? And nothing more. You got it? You see that? Good. So let's see. So if the big question is how much, and it's how much now, it's a question about P0, the big answer is nothing but the expected benefits. Is nothing but, the expected benefits. In finance, we say payoffs. In finance, in academic terms, we say payoffs. But benefits are very natural. No problem. You got it? So the big question is how much? The big answer is benefits. The big answer is what? Is benefits, right? But benefits is a future-oriented term, right? Benefits is a future-oriented concept. Benefits are all about the future, right? Because you are to receive those benefits sometime in the future, right? You are not getting the benefits now, right? You are going to get and receive those benefits over the life of the asset we're talking about, right? And therefore, we're talking about the future. We're talking about what? We're talking about the future. We're talking about time. The future is time. The future is tense, right? It's time, right? And therefore, we're talking about time, right? And time is not free, right? Time has a cost, right? Time has a dollar value. Time has a dollar value. And therefore, the way to get from the big question to the big answer, right? Or I'm sorry, the way to get from the benefits to answering the big question is somehow to consider time and the value of time and the price of time. You got it? And the price of time. So that big question is connected to that big answer via the toolbox. Via what? Via the toolbox. Via what? Via the toolbox of time and the price of time. And what? And the price of time. The price of time. Okay? So again, what is finance? It's the big question of how much. It's the big question of asset pricing, right? Right? It's the big question of P0. Our question is about now. You got it? What's now? What's now time-wise? It's the present, right? So we're asking a question about the present, right? And the answer, the present in finance, depends on our expectation of the future, right? And what the future has in store for us, it has benefits. It has what, It has benefits, right? So P0 is nothing but expected benefits. But in order to go from the benefits, back to P0, we have to employ the toolbox of time and the price of time. Of what, Of time and the price of time, right? Good. So time is T in finance. Time is T in finance. The price of time in finance is what we call R. Is what we call what? Is what we call R. And R is for return. R is for what? R is for return. We're going to be talking in great detail about R throughout the course. But for now, just take it. Take it as R. And know this much about it. It's the price of time. It's what? It's the price of time. What determines the price of time? How can we possibly make sense of it? Is going to be exhausting a great deal of this course. Okay, but for now, just take R for the price of time. So again, what is finance? What is finance? It's the big question, a big answer, and a toolbox. You got it? It's a big question, a big answer, and and a toolbox. It's the big question of how much. In academic terms, this is what? This is asset pricing, question mark. This is what? This is asset pricing, question mark. It's P0, question mark. The big answer of expected benefits. And this is a very natural way to think of it. How much would you pay for anything is exactly how much benefits you are expecting to get out of it, right? This is nothing fancy, Joe. It's very simple. In order to go from the benefits back to the P0, well, my question now, do we have to go ahead of time or do we have to go back in time? In order to go from the benefits to P0, do we have to go ahead of time or do we possibly have to go back in time? Yes, sir, we gotta go back in time. You got it? We gotta go back in time because the benefits come in the future, whereas our question has to be answered now. So we gotta go back in time from the benefits, of course, right? So the way to go back in time from the benefits to P0 is via entertaining what? Is via entertaining the toolbox of time and the price of time. You can think of that toolbox in terms of a time machine with an admission fees. This is how I see it. And I can never think of it any simpler. It's nothing but a time machine with an admission fees. You got it? The time machine is T, some sort of like, and the admission fees is the price for the time machine. You got it? So what kind of toolbox we have in finance? Simply a time machine with an admission fees. You got it? A time machine that is not free. A time machine with an admission fees. Yes, sir?
Can I say time and time value?
Of course, of course. The price is a value. The price is a value. So the price is definitely a value, and of course we can say the value of time or simply the price of time. In finance, the price and value are synonymous. In all of economics, by the way, the price, and now in modern economics, the price and value are synonymous. We don't have that philosophical distinction between what's a price and what's a value anymore, okay? So for now, now in modern economics, price and value are strictly synonymous. And therefore, when I say pricing, meaning valuation. Pricing and valuation are synonymous, right? Pricing and valuation are synonymous. So yeah, of course, you can say value, no problem. You can say value. So have any questions so far, guys? Any questions so far? So again, the big question of how much, the big answer of expect benefits, and the toolbox of time and the value of time. We can collectively think of that toolbox in terms of a time machine that is not free, in terms of a time machine with an admission fees. You got it? Time machine with an admission fees. You got it? All right, let's go ahead and apply that framework. So if I were to ask you about finance, if someone were to ask you about finance, what would you have in mind? What would you have in mind? You're gonna be having in mind this exact framework. A big question of how much, a big answer of expected benefits, and the toolbox of time and the value of time, right? Time is T in finance. Time is what? Time is T in finance, and the price of time is what? Is R. The price of time is R. You got it? So let's go ahead and apply that very simple concept, that very simple framework. Okay, so suppose you now have $100, right? Suppose you now have $100, right? How much will you have after 1 year, right? After 1 year at R of 10%. Well, let's think of it. So this is my question. Suppose you now have $100. Suppose you now have $100. How much will you have after 1 year at R of 10%? Well, what are we going to be solving for? We're solving for the value after 1 year, right? After 1 year's future, right? And therefore it's F, right? And the index is going to be 1, right? Right? So if you now have $100, how much you're going to be having exactly 1 year ahead? You're still going to be having the $100. Those are not going to be going anywhere. See how I think of it. Yeah, of course, of course. But see how I think of it. See how I think of it. This is very important. My question again, this is a very simple question. I like to take my time with it because it is going to be forming a very decent foundation as far as like finance education is concerned. Suppose you now have $100. Suppose you now have $100. How much you're going to be having exactly after 1 year at a rate of return of 10%, at R of 10%. What's R again? It's the price of time. What's R again? The price of time. So where's time here? Let's define the toolbox first. Let's define the toolbox. The toolbox is made up of T and the price of T, right? So how much is T? How long is T? 1. It's 1 year. So T is what? T is 1 year. The price is what? It's 10%. The price is what? 10%. So we have defined the toolbox. Let's go ahead and answer the problem, right? Good. So how much you're going to be having after 1 year? Okay, now listen how I think of it. How much I'm going to be having after 1 year? Is it still the $100? Those are not going to be going anywhere because this much I started with, right? So those are not going to be going anywhere. I started with $100 and therefore I'm still going to be having them after 1 year. But in addition to that, I'm going to be having the return on them. I'm going to be having what? The return on them, right? So the return on $100 is how much? Is 10%. And 10% out of 100 is how much? It's $10. So I'm going to be having the 10% over the 100, over my initial. I'm going to be having the return over my initial. And my initial plus the return on it is exactly how much I'm going to be having after 1 year. You got it? You see how I think of it? So how much are we going to be having after 1 year? We're going to be having the initial, which is what? Which is 100, plus the return on it. Plus what? Plus the return on it. Plus the return on it. The return on it is how much? It's 10% times the initial. It's 10% of the initial, right? The return on the initial is how much? It's 10% of it. It's what? It's 10% of it, right? Which is $10. Which is what? Which is $10. So at the end of the day, how much you're going to be having after 1 year? You're still going to be having the initial. Those are not going to be going anywhere, right? In addition to that, you're going to be having what? You're going to be having the return on them. You're going to be having what? The return on them. So this is what we have so far. This is the setup we have so far. Let's simplify it. So we can, if you eyeball it very simply, you can go ahead and factor out the 100, right? So if you do that, you're going to be factoring out the 100, and you're going to be ending up with 1 plus 10%. So this is how much you're going to be having after 1 year. This is how much exactly you're going to be having after 1 year. You got it? You see that? Any questions? Very natural, right? Very natural. You're going to be having after 1 year, if you start with 100, after 1 year, you're still going to be having the 100 plus the return on the 100. Plus what? plus the return on the 100, right? And you can simplify the mathematics and end up with that, right? So F1 is nothing but 100 times 1 plus 10%. You got it? So this is a very natural way to think of it. Now, how much we're going to be having after a couple of years? How much we're going to be having after a couple of years? Let's see how. So how much we're going to be having after 2 years? After 2 years, how much we're going to be having? How much are we going to be having after 2 years? Tell me, where's time?
100.
Now time is 2. It is not 1 anymore. And R is still 10%.
Yes.
R is still 10% per year. You got it? So we have defined the toolbox, nice and simple. Let's go ahead and answer the question. Well, first, what are we going to be solving for? We're going to be solving for F2. We're going to be solving for F2. So this is not a problem about F1. It's a problem about F2 because what are we looking for? We're looking for how much we're going to be having after a couple of years, which is F2. Which is what? Which is F2. Great. So we're going to be solving for F2. Now, how can we possibly make sense of F2? Well,
100.
thank you so much. Thank you so much. How much you're going to be having for F2, right? Is F1, is what, Is F1 plus
F1.
plus the return on it. Plus what, Plus the return on it. It's nice and simple, right? So it's, you see, it's recursive, right? So we're going to be having F1 plus, plus the return on it. Plus what, Plus the return on it. So we're going to be having F1 plus what, Plus 10%, right? 10% of F1, right? Right? Well, let's solve for it. So how much is F1? How much is F1?
100
Was 100
plus
times 1 plus
10%.
10%, right? Right? Now plus what,
10%.
Plus 10% times F1. And how much is F1? It's 100 times 1 plus 10%. Right? Right? Now we can factor out the 100. We have a couple of terms here, right? We have what, We have a couple of terms here, right? And what we have a couple of terms, right? And we have a common factor. Tell me about the common factor. The common factor is 100 times 1 plus 10%. So we can go ahead and factor that out, right? Well, if you do, what are we going to be getting? Let's go ahead and factor it out, right? So what are we going to be factoring out? We're going to be factoring out the F1, right? So let's solve it from here. It's easier to do it here. So let's go ahead and solve F1. So factor F1. So factor F1, and what are we going to be ending up with? We're going to be ending up with 1 out of the first term, right? Plus 10% out of the second term, right? Right? Now let's just like make mathematics look nicer. So how much is F1? It's 100 times, 1 plus 10% times, 1 plus 10%. Which is what? Which is what? Which is 100 times 1 plus 10% to the power of 2, which is 100 times, 1 plus 10% to the power of, to the power of 2. So this is F2. Nice and easy. You got it? And we did it purely algebraically. We're not talking about finance or economics yet. We're talking about simple logic. We're talking about elementary mathematics here. You got it? So we're doing very well. We're answering questions we're answering finance questions with elementary mathematics. So this is great. We haven't yet started with finance, by the way. So we have any problems here? So this is what we have for F1. It's 100 times 1 plus 10%. And for F2, it's going to be 100 times 1 plus 10% to the power of 2. So you have questions?
Yes.
Of course.
Sorry. Just can I ask you about first line. What did you do?
Here, you're asking about this equation?
Yes.
Here?
Yes.
Great. So we have F1 plus 10% times F1, right? So I factored out F1, right? From the first term, I'm going to be ending up with 1. F1 over F1 is 1, right? And 10% F1 over F1 is 10%. So I just factored out the F1 and solved. You got it? And substituted here. You got it?
Yes.
You see that? So the point to go home here is that F1 is going to be 100 times 1 plus 10%. It's going to be 100 times 1 plus R, right? And F2 is going to be 100 times 1 plus R to the power of 2, right? Well, let's go ahead and generalize. If what you have now is P0, if what you have now is what, Let's call it P0. If what you have now is P0 in general, it can be $100, it can be $10, it can be $1 zillion. It doesn't matter. Let's just call it P0 for generals. You got it? If what you have now is P0, how much you're going to be having after n years? N can be 1 year, can be 2 years, can be 0 years, by the way. It can be 1 zillion years. Let's see. So how much we're going to be having after n years? Well, if you're following me, if you're following me and digesting this kind of purely mathematical and simple logic, you would tell me that after n years, we're going to be solving for Fn. We're going to be solving for Fn. And Fn is nothing but P0, right? Times 1 plus R to the power of n. Thank you so much. To the power of n. To the power of to the power of n. To the power of what? N. This is very profound. This is the very first relationship you ever have to learn in finance. You got it? This is the very first relationship you have to learn in finance. Because the inverse of it, well, to your surprise, defines all of finance. You got it? So this is very nice. It's so profound because we're going to be doing some trick to it now. And just out of that trick, we're going to be defining all of finance. We're going to be defining all of finance. We're going to be defining all of finance. You got it? Any questions? Any questions here? Any questions? Guys? Okay, so what did I do? Or what we have now, where we stand now. Where we stand now, let's see. Are we done here?
Yeah.
Great. Are we done here? Good. So this is what we have now. Let's just comment on it and talk a little bit about it. So this is what we have now. It's Fn. It's what, Fn equals, tell me please. P0.
Times
Yep.
1 plus R.
to the power n.
You got it? You got it? So this is what we have so far. Okay. Now, we restricted our time definition to n. We restricted our time definition to n. And n is the number of years. N is what? N is how many years, right? But what about the periods within the year? What about what? What about the periods within the year? Within what? The year. So what's n? N is simply the number of years. N is what? The number of years. So what's n here? What's n? N is what? Do it here. So what's n? N is nothing but the number of years, right? By definition. This is how we thought of it, right? Right? What about the periods within a year? What about what, huh? What about the periods within, huh? Within a year. What about the periods within, huh? Within a year. Well, if you think of the year in terms of one period, how many periods? One. If you divide the year in terms of a couple of halves, semi-annual, how many periods?
2.
If you think of the year in terms of a quarter, in terms of quarters, how many periods?
4.
4. If you think of the year in terms of months, how many periods?
12.
If you think of the year in terms of days, how many periods? 365, right? 365. So let's go ahead and allow our time definition. Let's go ahead and talk. Let's go ahead and make our time definition to allow for the periods within a year. For the periods within, within a year. Let's call the periods within a year M. Let's call them what, M. And what's M? What's M? This is the periods. This is what, The number of periods within, Number of periods within, Within a year. Number of periods within a year. Number of periods within, Within a year, right? Let's go ahead and make it the number of periods within a year. Now tell me, if M is 1, so what are we talking about? We're talking about annual. We're talking about what, We're talking about annual. We're talking about what, We're talking about annual. We're talking about annual R. We're talking about what, We're talking about annual. You got it? Well, if M is 2, so how many periods we have within the year? How many periods? We have 2 periods, and therefore we're talking semi-annual. We're talking, semi-annual. You got it? Well, if M is 4, therefore how many periods are within a year? 4 periods. And what are we thinking of? We're thinking quarterly. We're thinking of quarters. We're thinking of, We're thinking of quarters. So this is quarterly. Right? What if M is 12? What are we going to be thinking of? We're going to be thinking of months, right? We're going to be thinking monthly. We're going to be thinking what, We're going to be thinking monthly. Annually is 1. A year is a period, right? The 1 year is 1 period. You got it? Semi-annually, the 1 year is 2 periods. Quarterly, the 1 year is 4 periods. Monthly, the 1 year, The 1 year is what, The 1 year is 12 periods, right? What about weekly? Thank you so much. Weekly is 52 periods. What about daily?
365.
365. Good. So M is 1. 1 year is 1 period, right? M is 1. What we have? M is 1. What we have, guys? 1 year is 1 period. M is 1. What we have? 1 year is 1 period, right? M is 2. What we have? 1 year is 2 periods. 1 year is what? 1 year is 2 periods. M is 4. What we have?
1 year is 4.
1 year is 4 periods, right? M is 12. What we have? 1 year is 12 periods. M is 52. 1 year is 52 periods. We're talking about weeks, right? M is 365. What we have? 1 year is 365 periods. What are we talking about? We're talking daily. We're talking about days here. You got it? A day is a period. Here, a year is a period. Half a year is a period. A quarter is a period. A month is a period. A week is a period. A day is a period. A minute can be a period. A second can be a period. Half a second can be a period. This concept can apply like forever, no problem. You see that? You can go much smaller. You can go like a lot tinier if you feel like to. But this is the concept we have, right? Right? How can we possibly allow for M in that definition? How can we possibly allow for M in that definition? Well, the way to allow for it is to, well, how much we have for M here? What did I assume here in that basic definition? What did I assume here? I took M for 1 in my basic setup. I took M for 1, right? But where does it belong? M is here,
Dividing by R.
right? And it's here too, right? Right? Because this is where time belongs into my setup, right? Right? This is exactly where time belongs in my setup, right? In my basic setup, I took M for 1. I took M for 1, right? And therefore, R is going to be over 1, and time is, you know, like assuming the power here, it's gonna be like 1 times n, right? But let's allow for m in general. Let's allow for m in general. So how can we possibly allow for m in general? Huh? What if m is not 1? What if m is anything? So if m is anything, it's just gonna be m, right? No problem, right? So if m is anything, it's just gonna be m, right? You got it? And this is what we have. This is nice now. This is very profound. You got it? This is very profound. Now we have allowed for the number of years. Now we have successfully allowed for the number of years and also for the number of periods within a year. The number of periods within a year. And we're very logically consistent about things so far. Right? We're not doing anything crazy. We're not abusing anybody's logic here. You have any questions so far? Good. Now let me talk a little about what's going on here. What's going on here? Philosophically. What's going on here? That setup. What's going on? Well, think of it. Of course. Are we done here? Can I take it off? Okay. Take your time. Yes, sir.
P0, what is it?
Huh?
At P0, what is it?
It's the value after any years.
I mean, that's the concept what you asked. Given the present,
Of course, yeah, of course. You answered my question. Thank you so much. Great, great. Thank you. Very smart. Samir? Muhammad, I'm sorry. Well, Hamza? Sorry. Hamza. And I'm confused here. Majid? Hassan. Right? Riyadh. Rayan? Okay, I'm sorry. Sorry. Now you guys are going to be famous because you're going to be like all over the video lectures and yeah. You're going to be all over the world now because people are going to be watching. And okay, so are we done, Hamdan?
Yes.
Great. If you have any questions, please stop me, okay? I know you're very sensitive about your privacy, and therefore I'm not going to be mentioning your name. No strings. I find this review very useful. You know, sort of like inculcating the ideas. We're inculcating the essentials. Finance is all about the essentials, and it's all about visiting the essentials with a new eye, perhaps. And this is what I like about today's lecture the most. Of course, besides the webcast. Okay, so are we done, Hamdan? Okay. Okay, so what's going on here? Let's talk about it a little. What's going on here? Think of it. Okay, what am I doing philosophically? What am I doing philosophically? What's P0? What's P0? Well, it's something about the present, right? 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 But what about Fn? What about Fn? This is some future. This is what, huh? This is some future, right? This is what, huh? This is some future. So what am I doing? What am I doing here? What's going on here? I'm taking the present and solving for, and solving for the future, and solving for, the future. I'm taking the present and solving for, the future, right? So it's as if like I'm telling you the future in mathematical logic. This is how things are in mathematical logic, right? Right? What's given now? What are we solving for? Be careful here. This is an important lesson of finance. This is an important lesson of finance because we're going to be learning a profound lesson just by the inverse of that relationship. You got it? So let's see what we have so far. So in mathematical logic, I'm telling you that the future, that the future depends on the present, on R, on M, and N, right? Right? So if you define the present, R, M, and N for me, I can tell you what the future is going to be. I can tell you what, You see what I'm driving at? You see that? So if we get together and you like somehow miraculously define for me the present, R, M, and N, right? I can retrieve the future for you. I can what? I can get you the future, right? So let's see. So this is a mathematical logic as if I'm telling you that the future depends on or is a function of, is what? Is a function of the present. Is the function of, the present, right? Is the function of, the present, R, M, and N, right? 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 This is what I'm doing here. This is what I'm doing here. You got it? So given the present R, M, and N, we can find out about the future. You got it? You got it? Good. So keep that in mind. This is very important. What if we go the other way around? And now we're coming very close into a profound conclusion here. We're coming very, very close into a profound conclusion. We're sort of like linking finance to philosophy here. What if I go the other way around? What if I just think of it the opposite? What if I solve for P0 given Fn? So are we done so far here? Are we done here? Good. So what if I solve for P0 given Fn? What should I do? So P0 is going to be how much in terms of Fn? Let's go ahead. Well, this is a mathematical exercise. It's simple. Of course, middle school mathematical exercise. Let's go ahead and solve for P0 given Fn. How can we do it? Any idea, bro? How can we solve for P0 given Fn? Yes, sir. P0 equals what? Tell me, bro. P0 equals Fn times, yeah, right? 1 plus, yep, to the power of? To the power of negative. To the power of what? To the power of negative Mn, right? Right? To the power of what? Negative Mn. You see the difference between this one and this one here? You see the logic? The logic is different now, right? Because I'm now solving for the present given the future. I'm now solving for, the present given the future. So what this tells me, what this tells us here, it tells us that the present, right, which is P0, is what? Depends on Fn, R, M, and N, right? This is what we have, and nothing more, right? This tells us that if we are given the future, R, M, and N, we can go ahead and solve for the present. We can go ahead and what, and solve for the present. We can go ahead and solve for, for the present, right? So let's go ahead and do that. So it's as if like I'm telling you the present is a function of the future R, M, and N. That's it. You see that? Huh? You see that? So the section below is nothing but the inverse of the section above, right?
Present is B.
Of course, present is P0.
After equal. Present equal B.
Present equals a function of.
Okay, so in the future equal also.
The function of the present. It's a function of. It depends on. Okay, a function of. In mathematical logic, it's a machine. It's a machine that takes on those inputs, right, and produces this output. It's a machine that takes in those inputs and produces this output, right? So what am I doing here? Tell me in English, what am I doing here? What am I doing here? I'm given the present and solving for the future, right? Here, are we going ahead of time or back in time? Well, the present is now, but we're solving for the future. So we're going back or ahead? We're going ahead of time. We're going what, huh? We're going ahead of time, right? We're going what, huh? Going ahead of time in finance is what we call compounding. Is what we call what, huh? Compounding. Is what we call what, huh? Compounding. So going ahead of time, this is what, huh? Going ahead on time. This is what we call, huh? This is what we call compounding. See, this is what we call what, huh? Compounding, right? This is going ahead of time. This is what, huh? This is going ahead of time. This is the present, right? And we're going ahead in time to the future. You got it? So this is what, huh? This is compounding. This is what, huh? Compounding. What about here? What are we going here? What we do here? What's going on here? What? No, tell me in English what's going on. Given the future, we're going to be solving for the present. So we're somehow at the future, right? We're crazy. We're somehow at the future. And now, are we going to be going ahead or back? Want to go to the present. And if you are the future and you want to go to the present, so you better be going, you better be going back in time. And going back in time is what we call in finance discounting. Is what we call in finance what, Discounting. Is what we call in finance what, Discounting. Thank you. So this is what? This is going back. This is what, This is going back in time. This is going back in what, In time. And this is what we do, this is what we call what, This is what we refer to as discounting. This is what we refer to as, Discounting. And how can we think of it? It's getting aboard a time machine and going backwards. Getting aboard a time machine and going what, Backward. Where are we now? We're here at Fn, right? Right? And we're going back to the P0, and we're going to be going back in time. You got it? Of course, we're going back in time. We're going back in time, okay? We have to talk to Mr. Gill about having for us like a bigger board in the future because we're webcasting the course and all. The guy's not cooperating, so it's not, I don't know. Ibrahim, you talk to him, perhaps you have to. No, in the future. Exercise your management powers and tell him. Okay.
Especially over professors.
Over Gil. So any questions here, guys? Any questions so far? Any questions so far? Okay, would you like to stop for 5 minutes for a break or so and come back?
Yes.
Good. So we're going to be stopping for 5 minutes break and we're going to be coming back. Okay, we're back. So we have defined now a couple of operations. We have defined a couple of operations, right? First, whenever we are solving for the future, given the present, the operation is compounding, right? But whenever we are doing the exact opposite, the operation is discounting. The operation is discounting, right? Let's go ahead and show them off in a little bit more detail. But let's first define finance from what we know so far. Let's first define finance from what we know so far. What is finance? Is it about solving for the future given the present? Or is it about solving for the present given the future? What is finance?
Present.
Of course, finance is about solving for the present given the future. Finance is all about, solving for the present given our expectation of the future. You got it? This is what finance is all about. It's all about solving for the present given our expectation for the future. So which mathematical operation finance typically adheres to? Is it compounding or discounting? It's discounting. Finance is all about discounting. Why this is so? Why finance is all about discounting? Why finance is all about solving for the present given the future? Because finance is all about answering the question of how much now. You got it? So finance is all about what? Is all about answering the question of how much now, right? We're trying very deeply to answer the question of how much now. And to answer the question of how much now, we have to have some kind of expectation of the future, right? And the way we solve the question of how much now is to go back from the future to the present, right? And the mathematical operation that makes that a possibility is what we refer to as discounting. Is what we refer to as what? Discounting. So finance is typically discounting. Finance is typically what? It's typically discounting. The opposite of finance is compounding. The opposite of finance is compounding. You got it? So finance, at least the academic finance, at least the academic finance is typically discounting. It's typically what? Discounting. We're going to be learning of the body of methods to somehow solve for the present given the future. And our toolbox again is nothing but T, right? Is nothing but T, right? And what's T here? What's T here? Well, T is all over the place. It's future, M and N, and what? And the price of T, which is R. You got it? So the way to go back from the future to the present is via like a toolbox, which we call like a time machine with an admission fees, right? It's a time machine with an admission fees where the fees is always R, where the fees is always what? Where the fees is always R. Let's go ahead and contrast compounding to discounting again, learn some insights. So let's go ahead and do that. Okay, so we have defined a couple of operations. We have defined a couple of operations. First, what's finance? What's finance? It's always discounting. It's always what? Discounting. The opposite is what? Is compounding, or the inverse. Or what? The inverse is compounding. So the philosophy here is what? The philosophy, let's define the philosophy. The philosophy for discounting What kind of philosophy for discounting we have, huh?
Given the future,
Given what?
the future.
So given the future, so at Fn, right? Right? P0 is how much? P0 is what, huh? Is how much, right? So this is what we do, right? So what about compounding? What's the philosophy? What's the philosophy?
Given the present,
Thank you.
how much?
So at P0, huh? Fn
How much?
is how much? At P0, Fn is how much? You got it? You got it? Okay. What about the functional form? The functional form. The functional form. The functional form. How the mathematics looks like. How the mathematics looks like. Let's see how the mathematics looks like. For discounting, what we have in the stock, how the mathematics look like. How the mathematics look like. It's P0. What are we solving for? What are we solving for? P0. What's the input? Fn. It's a function of, huh? It's a function of, huh? Fn. Right? It's a function of, huh? Fn. R, M, and N. Right? You got it? It's a function of Fn, R, M, and N. R, huh? M and N. Great. What about compounding? How the mathematics look like? What about compounding? How the mathematics look like? Think about it. So it's what, huh? It's Fn equals, huh? Equals a function of P0. Thank you so much. R, M, N. Right? So this is how the mathematics look like. You got it?
Yes.
You have questions about it? Huh? Thank you so much. So what about the profile here? Let's have an image. Let's have some visual. So what's a profile? Okay guys, let's have a profile about Majid here. So for discounting, Majid's way, is it gonna be ahead of time or back in time? So where is Majid now? Where is Majid now? He's gonna be going back in time. So where is Majid now? Majid is here, right? So Majid, this is Majid with eyeglasses and all. Okay. Okay, this is Majid with eyeglasses. And he's gonna be going, huh? He's gonna be going aboard this time machine back in time to the present, right? Right? So this is Majid, square face and all, is going back in time. Okay, to P0. You got it? So what about compounding? Let's have Majid's profile here. Huh? So Majid, is he gonna be going ahead of time or back in time here? Compounding. He's gonna be going ahead of time. So where's he now? Where's Majid now? He's here. Majid is here now. Okay. This is Majid. Okay. Of course. And he's going ahead of time aboard this time machine, and his destination is Fn. Got it? You see that? Huh? So you have any problem with Majid here, guys? Okay. So here, Majid is going to be going ahead of time. That's compounding. Here, he goes back in time. That's what? Huh? Which is the finance way? Ahead of time or back in time? Back in time. Which is the finance way? It's back in time, right? So getting aboard a time machine and going, huh? And going backwards. And going what, huh? And going backwards. You got it? Good. So, listen, well, this is very interesting, but we're talking about return and time, right? We're talking about return and time. This is pretty much the toolbox in finance, right? But prices, or okay, again, so finance, the big question of Asset pricing, right? The big answer of benefits, expected benefits, and the toolbox of R and T, of what? Of T and R, of what? Of T and R. And what's R? The price of T. That's the value of T. You got it? That's the dollar value of T. You got it? All right. So what about benefits here? Let's talk a little about benefits. What about benefits? Okay. Benefits in finance can show up in three forms. Benefits in finance, future benefits can show up in three forms. Can show up in what? In three forms, right? They can show up as a single sum. They can show up as what? As a single sum, right? They can show up as an annuity, and they can show up as a perpetuity. They can show up as what? As a perpetuity. So how many forms benefits can show up at in finance? Three forms, right? Three forms. So we have the first form benefits can show up at is what we call a single sum. Is what we call what? A single sum. The second form benefits may take in finance is what we call annuities. What we call what? Annuities. And the third is what we call perpetuities. The third is what we call what? Perpetuity. There is no fourth form benefits may take in finance. That's it. You got it? There is no fourth form benefits may take in finance. That's all. So benefits can come in as a single sum, right? They can come in as annuities or as a perpetuity, right? There is no fourth form to benefits in finance. Yes, sir?
When you said like benefit, you mean like right now it's like in the present?
Benefits in the future, of course. Benefits are all about the future.
So it's not about finance.
Benefits are all, no, of course it's finance, because benefits are all about the future, and you're going to be taking that future back to the present.
Oh, okay.
Okay? It's about what you're going to be doing with the future. You see that? It's about what you're going to be doing with the future. So once you have an idea about it, you're going to be taking it all back to the present. You got it? Thank you. So a single sum, right? They can show up, they can come in as an annuity, and they can come in as a perpetuity. Now what's a single sum? What's a single sum? Well, a single sum, yes sir?
One time.
Thank you so much. Great. Thank you. Very smart. So a single sum is a one-time amount. Thank you so much. Thank you so much. It's a one-time amount. It's what, It's a one-time, it is not periodic amount. It is not an amount every period. It is not an amount every year. It is not an amount every month. It is not an amount every week. It's a one-time amount. It's what, It's a one-time amount. It's a one-time lump sum. It's a one-time what, It's a one-time lump sum, right? It's a one-time amount. So what's a single sum? One-time amount. And thank you so much, Muhammad. Thank you so much for it. It's a one-time amount. What about an annuity? What about an annuity? It's a periodic single sum for sum n. For what, For sum n. So it's a periodic single sum for sum n. So it's a single sum every period. It's a single sum every m for sum n. You got it? You got it? So what's an annuity now? It's a periodic single sum for sum n, right? What's a single sum? One-time amount. What's an annuity? It's a periodic single sum for some number of years. For some what, For some number of years, right? What about a perpetuity? What about a perpetuity? It's a periodic single sum for infinity. For what, It's a periodic single sum forever. It's a periodic, It's a periodic single sum for forever. So tell me again, single sum, annuity, perpetuity. Single sum, annuity, perpetuity. What's a single sum?
One-time amount.
Thank you, one-time amount. What about an annuity? A periodic single sum for sum n. Bravo. What about a perpetuity? A periodic single sum for infinity. For infinity. Okay, good. Let's see what we have. Let's see what we have in the store for a single sum. How can we possibly discount a single sum? We saw it, right? So tell me what to do now. It's going to be P0
equal
equals Fn, bravo, times
times
1 plus R over M to the power of
minus m
to the power of negative Mn, right? This is what a discounting a single sum comes down to, right? What about compounding a single sum? What about compounding a single sum? It's Fn. Now instead of solving for P0, we're going to be solving for Fn. So it's going to be Fn equals P0 times 1 plus R over M to the power of Mn, right? It's going to be what, Fn equals P0 times 1 plus R over M to the power of Mn, right? Okay, we're back. What about an annuity now? What's an annuity? What's an annuity? It's a periodic single sum for some n. It's a periodic single sum for some n. And how can we possibly discount an annuity? Well, I'll give you the proof for it later, right? I'll give you the proof for it later, but just learn it as it is for now, okay? Just learn it as it is for now. I'll go ahead and give you the proof for it perhaps in the very near future, but just learn it as it is now. This is perhaps the only thing that you have to learn as it is for today. That's it. Okay, and perhaps this is the only thing that you have to learn as it is in the entire course, okay? You won't learn it as it is, by the way. You just learn it as it is today, but in the near future, I'll give you the proof. The proof is simple, but we don't have time for it today. So the annuity, how can we possibly discount? Again, what's an annuity? It's a periodic single sum for some n. So the question is, how can we possibly discount a periodic single sum for some n? Well, the answer is going to be simple. Again, we're going to be solving for P0
equal a.
Okay, and let's define the annuity as A. Let's define the annuity as A. So annuity A. Annuity what? Annuity A. So the periodic single sum we're talking about, the periodic single sum for some n we're talking about is $8. Is what? Is $8. The periodic single sum we're talking about is $8. Yes, Muhammad?
I'm just wondering about what does it mean?
Annuity? Annuity, it's a periodic amount in English. It's a periodic amount. It's a periodic dollar amount. You got it? But we distinguish an annuity from a perpetuity based on the n dimension. For an annuity, there is some n. For a perpetuity, there is an infinity, right? There is an infinity. You got it? Good. So let's see how we do it. Tell me, it's P0 equals,
Equal
A, right, times 1 minus 1 plus R over M to the power of negative Mn over R over M. You got it? So this is how we discount an annuity in finance. How can we compound an annuity in finance? Well, this is very smart. So how can we do it? Now we have a discounted annuity. Now we have what? Now we have a discounted annuity, right? Now we have a discounted annuity, and it's how much? It's P0. But P0 is what? When you're done discounting an annuity, what are you going to be having? You're going to be having a single sum, right? So P0, though the outcome of an annuity discounted, right? It's indeed a single sum. P0, though the outcome of an annuity discounting is in fact a single sum, is in essence a single sum, right? So now, how can we possibly answer the future of compounding an annuity? Boils down to nothing but compounding a single sum, right? And the single sum we're talking about is the outcome of an annuity discounting, right? So in order to answer the question here, we have to compound P0, but we know that P0 equals A times 1 minus 1 plus R over M to the power of negative Mn over Rm, right? And we solve all of that, and we're going to be going home with an annuity compounded, right? So let's see how we do it very carefully. So now, let's do it. So Fn is going to be what? Fn is going to be what? Let's go ahead and compound the single sum, right? Let's go ahead and compound the single sum first. It's going to be what, huh? P0 times 1 plus R over M to the power of Mn. But how much is P0? How much is P0? Let's substitute P0 for the left-hand side here, right? Let's go ahead and do that. So it's going to be A, right? Right? Times, 1 minus 1 plus R over M to the power of negative Mn over R, right? Over M times 1 plus R over M to the power of, Mn. When you do the math, what are we going to be ending up with? We're going to be having A times 1 plus R over M to the power of Mn minus 1 over R over M. That's it. So this is what we're going to be having. I hope this is clear. You got it? Huh? This is very simple mathematics. It looks somehow convoluted, but it's very simple. You got it? When you're done copying, I'll just take it off. I'll just take off this hassle and just like keep the nice, simple, nice looking formula. You have any questions, Abdullah, today? You have any questions, Muhammad?
Thank you.
Yeah, Ahmed? Okay. You have any questions, Majid? Riyadh? Rayan? You have any questions, sir?
No, thank you.
You have any questions, Abdurrahman? No? And you, Nasser, you have questions? Are we done? We're done copying today? Okay, so this is where we stand now. It's
Doctor, I have a question. If we said Fn equal A times the last formula,
yeah.
is it okay?
Of course. This is what we're after. I'm just giving you a proof. Of course, yeah. Of course. So what we have here is Fn equals what? Tell me again. After we're done with the proof, what we have here?
A
Fn equals A, thank you, times 1 plus
R
over
M
to the power of
Mn
minus,
1
right, over,
R
right,
by M.
thank you. Right? So this is what we have, right? Good. Let's go ahead and see how things are with the perpetuity. So let's go ahead and see how things are with the perpetuity. First, what's a perpetuity? What's a perpetuity? It's an annuity for infinity, right? It's a periodic single sum for infinity, right? It's a single sum per m for infinity. You got it? As opposed to an annuity, which is a single sum per m for n. Now it's a single sum per m for infinity, right? Good. So how does it look like to discount a perpetuity? Think of it. How does it look like? Well, what we have to do here in order to allow our mathematics to discount a perpetuity. So what we do? Well, to allow mathematics to discount a perpetuity, what we do, think about it. What we do?
We replace N.
Right. We take the limit as n approaches what? As n approaches infinity, right? So we have to take the limit as n approaches infinity, right? Right? Okay, so if you do that, if you make n, what we mean by n approaches infinity? What we mean by n approaches infinity? We mean nothing but allowing n to be very, very large. To be very, very what, huh? To be very, very large, right? Infinity is a notion, right? Infinity is a notion that is not reached, but rather approached, right? So we can never get to infinity, but we can always come closer and closer. We can always what, huh? And this is the idea behind the limit here. This is the idea behind the limit, okay? So though we cannot replace n for infinity because we can never get to infinity. Nothing gets to equal infinity, right? But infinity, of course. Nothing gets to equal infinity but infinity. So we can never replace n for infinity, right? But we know we can always come closer, and this justifies taking the limit. This justifies what, huh? Taking the limit. So if you take the limit as n approaches infinity, you are doing nothing but allowing n to become very, very large. To become what, huh? To become very, very large. If you do that and allow n to become very, very large, what would become of that term? Well, so you're going to be allowing n to become very, very large and multiplying it by negative m. And therefore, you're going to be ending up with negative something very, very, very large, right? But that negative very, very large is on the power, right? And therefore, it's going to be bringing that entire term to 0, right? It's as if like you're dividing something by something very, very, very large, right? Right? It's as if like you're dividing something usual by something unusually large. So how much you're going to be ending up with? You're going to be ending up with 0, right? It's very simple. You're dividing something usual by something unusually large. And how much you're going to be getting?
0.
Of course 0. So you're going to be getting 0 here. So 1 minus 0 over r over m, and therefore 1 minus 0 is 1, of course, right? So we're going to be getting 1 over r over m times a, which is what? Which is a over r over m, right? So the outcome of discounting a perpetuity comes down to the nice looking a over r over m, right? And if m is 1, right, it's going to be even nicer looking. It's going to be a over r. You got it? You see that? We're going to be using that a lot. This is very simple, but it has profound implications in finance. When we do like equity evaluation, for example, this is a major framework for equity evaluation. You got it? Now we come to the question of compounding a perpetuity. How can we possibly compound a perpetuity? Think of it. We're going to be doing the same thing again. How can we do it? To compound a perpetuity? Think of it.
We replace n with infinity.
We don't replace n with infinity. We take the limit as n approaches infinity. Be careful. We can never replace n for infinity. Nothing gets to equal infinity but infinity. N is not infinity, but n can become so large that it becomes closer and closer to infinity. You got it? So this is done with the mathematical apparatus of the limit. You got it? So now let's go ahead and take the limit as n approaches infinity. When that happens, this is going to be what?
Minus a.
This is going to be what?
Infinity minus 1.
This is going to be infinity minus 1, right? Because infinity is going to be a positive power, right? So it's as if like you're raising something usual to something unusually large. How much you're going to be having? Infinity. You see that? When you're raising something usual to something unusually large, how much you're going to be having? Infinity. Infinity minus 1. Infinity. 1 doesn't matter. Nothing matters, right? Infinity over r over m. Infinity, of course. Infinity times a. Infinity. Fn. It's unrealistic, right? Because we can never have an infinity of dollars. We can never have what? An infinity of dollars. So, but mathematically, the outcome of compounding an annuity, a perpetuity, is always infinity. It's always what? which is not realistic, which is not a sense maker in finance, which is not what, huh? Which is not applicable in finance. Why? Because no asset can ever promise you an infinity of dollars. No asset can ever promise you an infinity of dollars. You got it? Or you would never wait. The precise argument for it, in fact, the precise argument for it is that you would never wait an infinity of time on an asset. We don't have an infinity of time to wait for assets. You got it? You see that? You see the argument here? And therefore, n is not applicable. Cannot be very, very large when it comes to compounding. When it comes to it, just the mathematics will tell us it's going to be infinity dollars. It's going to be what? Huh? Infinity of dollars. But what's an infinity of dollars? If I were to tell you, okay, I have an asset that promises you an infinity of dollars after an infinity of years, we're not going to be having a deal, right? You see that? But the mathematics will tell us, okay, it's Fn equals what? Huh? Equals infinity. But you know very well that this is not applicable in finance. This is not applicable in finance, okay? You got it? I hope I explained myself well enough here. If you have any questions, please ask me. You have questions today? Huh?
It's clear.
We have questions?
It's clear.
Okay, would you like me to stop here and continue next week? So this is a revision of something we did. Wait, this is a revision of something we did. Okay. The first week of classes, I hope this is fruitful enough for now. Next week, inshallah, we're going to be doing some exercises, right? A lot of exercises, because very soon you guys have to be answering to a midterm and some kind of quizzes and all. And therefore, the class next week is very important. I hope to see you all well and healthy. I'll see you then. Thank you.